In this video, we want to solve the differential equation. So first, let's solve the homogeneous differential equation by setting it equal to 0. Assume the solution is proportional to e lambda x. And so we're going to substitute y equals e lambda x into this homogeneous differential equation. Take the derivatives. Now we can factor out e lambda x and have lambda squared plus 3 lambda plus 2. Now factor that again into lambda plus 2 and lambda plus 1 and get lambda as negative 2 and negative 1. Now we're going to set these equal to the exponents for the general solution. So it'll be c1 e to the negative 2x plus c2 e to the negative x. Now we're going to set y sub a equal e to the negative 2x and y sub b equal e to the negative x. And we're going to compute the Wronskian. So for that, what you have to do is first row set the y sub a and y sub b, and the second row you want to take the derivatives of those. So the derivative e to the negative 2x is negative 2 e to the negative 2x. The derivative e to the negative x is negative e to the negative x. So compute the determinant, so multiply the first diagonal, negative e to the negative 3x, minus, now multiply the second diagonal, negative 2 e to the negative 3x. This turns into plus, and so you have e to the negative 3x. And that's our Wronskian. Let f of x equal sine of e to the x. V sub 1 and v sub 2 will be part of our solution, and they'll be in this form. So we have all the pieces. In the previous slide we had y sub b, y sub a, and the Wronskian, and then f of x is just sine of e to the x. So the particular solution will be given by y sub p of x is v sub 1 of x times y sub a of x plus v sub 2 of x times y sub b of x. So let's calculate v sub 1, and y sub b there was e to the negative x, and then the Wronskian was e to the negative 3x, and then sine of e to the x is just f of x. So e to the negative x over e to the negative 3x is e to the 2x. For this, we integrate, use integration by parts, and so end up with e to the x times cosine e to the x minus sine times sine of e to the x. Now let's find v sub 2. Same thing. E to the negative 2x over e to the negative 3x is e to the x. Here we use a u substitution. U equals e to the x. So you just have sine u du. And so you get negative cosine e to the x as an integral. So remember, the particular solution is in this form. So multiply what you have. So this was, from the previous slide, v sub 1 of x. This is y sub a of x. And this is v sub 2. And this is y sub b. This simplifies because we have these two will cancel once I multiply this over, and I'm left with negative e to the negative 2x times sine of e to the x. And so this was our y sub p of x. So we want to combine this with the original solution, with the homogeneous. So this was the homogeneous when we set the differential equal to 0, and this was our y sub p. So add these two together, and this is my solution.